All right, this is the day we've been waiting for. We are going to learn how to solve a quadratic that's not like an easy one where you just get to undo the square root. And we're going to do that by factoring. This is also sometimes called solving using the zero product property. That's what our book calls it. All right, so let's say that you have a parabola and you want to figure out what the X intercepts, the roots of that parabola are, but they don't line up at nice numbers, right? Like you can sort of estimate it, but they're not exact and you can't figure it out. So we want to solve algebraically. How do we do that? Well, let's think about lines. What do we do when we want to solve for an X intercept? We know that the X intercept is always where y equals 0, right? That's always your X intercept when y equals 0. So likewise, with a quadratic, we would take our rule, whatever it is, y equals a x squared plus bx plus c, and we would put a 0 in place of the y. So we'd have 0 equals ax squared plus bx plus c. So this is the thing that we need to solve to find the x-intercepts. Now, the only problem is we don't know how to solve those yet. That's what this video is for. So let's take an example. Let's say we were looking at the quadratic y equals x squared plus 7x plus 12. And we want to find the x-intercepts of this. So we're going to do 0 equals x squared plus 7x plus 12. Now, you might think you know how to solve this. If you look at that and you're like, yeah, I know what to do, pause, take a minute, give it a shot, see what happens. Now, if you were to play around that way, I'll do it real fast, just over in the corner. You might start by subtracting 12, maybe you take away 7x, negative 12 minus 7x equals x squared. Now we're going to take a square root, so we have square root of negative 12 minus 7x equals x, which is like all good and fine and stuff, except that you still have an x under there, right? Like you can't combine your like terms in order to be able to solve because you've got an x and an x squared, right? So this doesn't work. We need a different strategy. And this is where what's called the zero product property comes in. Okay? So, slight detour. We're going to come back to this, I promise. Zero product property. Now let's say that I know that there are two numbers, a and b, and that when I multiply them together, I get 0. That's all I know about them. What can I deduce from this fact? Take a minute and think about it. When I multiply them together, I get 0. What must be true? Hopefully you've decided that one of those numbers must be 0. So either A or B must be 0, right? Like 245 times 0 would equal 0. Negative 15 times 0 would equal 0. 0 times 295 would equal 0. Seems like my 200s. So this is our zero product property. It says that if two things multiply together to equal 0, then one of them must be 0. Now how is this helpful? This doesn't have any multiplication in it. Oh, but wait, it can if we factor. So we are going to factor x squared plus 7x plus 12 using a box and diamond. Maybe you're getting good enough at this that you think you can do that one in your head without needing it. If so, go for it. Great practice. If not, totally cool. Just do the box and diamond like I taught you. if we've decided that this equals x plus 3 times x plus 4. And remember, we're trying to solve for when this equals 0. So if two things multiply together and equal 0, then one of them has to be 0. So that means that for this equation to be true, then either x plus 3 must equal 0, or x plus 4 must equal 0. What values of x would make that true? We can just solve the equations. Get x equals negative 3, and we get x equals negative 4. So that means that there are in fact two solutions to this equation, both x equals negative 3 and x equals negative 4. How is it possible that we have two different solutions to the same problem? Well, remember what we were talking about to begin with? These are like the roots or the X intercepts of the parabola. And to confirm that they work, we can plug them one at a time back into the original problem and see that when we plug in negative 3, we do get 0 for y, which is what we need to have an X-intercept, an X value, and then y. Let's do it real quick. So first I'll try it with x equals negative 3. So I guess I'll leave it at y to begin with. Y equals negative 3 squared plus 7 times negative 3 plus 12. So 9 minus 21 plus 12 does equal 0. So that one works. If I plug in negative 4, it's the same idea. Y equals negative 4 squared plus 7 times negative 4 plus 12. 16 minus 28 plus 12. And yes, that does equal 0. So they both work. So just to summarize here, finding the roots of a parabola is the same thing as solving for when y equals 0. And it just so happens that we have a lot of strategies for solving quadratics, but a lot of them boil down to solving for when y equals 0. So even if you want to know something else, you'll kind of like change it into the form where y equals 0 before you solve. Okay, which is why we like use this context a lot for solving quadratics. Okay, let's do another example. This time, I want you to solve 2x squared plus 5x minus 12 equals 0. Solve that quadratic, please. Pause, see if you can figure out what to do. Did you decide to start by factoring? That's a good thing. Actually, the very first thing you should do is check and make sure it equals 0. Is it set to equal to 0 is usually the way I say it, so I'll write it that way. Is it set equal to 0? If not, subtract from both sides until you can make it equal 0, and then proceed with the next step. 2. Factor. If factoring doesn't work, then you're going to have to move on to a different strategy that you haven't learned yet. Okay? So factoring is going to work for this one. So we're going to do our generic rectangle and our diamond problem. Okay, and so I factored it now, so now I get x plus 4 times 2x minus 3 equals 0. That was my factoring step. And so then the next thing I do is solve for when each factor equals 0. So sometimes it's easy to do them in your head, so like x plus 4 equals 0. It's pretty easy to see that that equals negative 4. Sometimes it is important to write it out to make sure you don't make a mistake. So like 2x minus 3 equals 0, plus 3, 2x equals 3, divide by 2, and x equals 3/2 or 1.5. So there are two answers to this equation up here. They are x equals -4 and 1.5. Depending on the context is why we would say either and or, right? I'm not too fussed either way. And once again, just like if you plugged both of these, if you plugged this number in up here, and if you plugged this number in up here, they would make it work, right? They would make the equation true. All right, for your practice problem, please solve 0 equals x squared minus 2x minus 8. Good luck.